Hello, Internet, and welcome to the show. This is my channel, and you're watching me, Brett, talk about containers, everything DevOps, Sysadmin. We're focusing on Sysadmin today because tomorrow is Sysadmin Day, which means if you have a Sysadmin role, then you hopefully will get like a cupcake or a thank you letter or something from someone, even if it's just an email or buying you a cup of coffee. If I was there with all of you and you were a sysadmin or any sort of sysadmin role, I would have a cup of coffee with you and we would talk about all the crazy tales of stories and memories that we have about the most ridiculous user request or the craziest server crash outage or, the worst virus we ever saw, that kind of stuff. So we can all commiserate around how sometimes quite challenging it can be to be in charge of computers and software. So today on the show, it's just me, and we're going to go through a bunch of stuff. It's going to be sort of rapid fire, going through examples of things. I'm looking forward to your questions because I want to hear the sort of operational or sysadmin focused stuff that you deal with and how to do that in containers, right? So if you have great tips, throw those in there too, because I don't know everything. So if you have your own ways about managing systems, deploying things, monitoring things, logging things, all that sort of stuff. The goal today is for you to learn something, for me to learn something, and talk about all the ways that you can do this job of a sysadmin, but do it inside a container. And first, I want to give you a little heads up on some things, some goodies we're giving away. Let's see. So up on my website, brettfisher.com/sysadminday 2019. First, we made a special coupon for all three of my courses. So you can get it at the lowest price that Udemy allows me to sell it at, which is $9.99. And you can use that coupon to get those courses if you don't have them. And we have obviously more courses coming, but most of you may know me from one of those courses. So thank you so much for your patronage. And if you're interested in anything else in that list, get them with that coupon. The other thing is, of course, this show is going to be on this page. And tomorrow, Ray, the intern who you may have met in a previous show here, he and I are going to be working the rest of the day. And tomorrow on building out a Docker, basically a GitHub repo that lists a lot of the sysadmin stuff. And I did some quick searching around this week and didn't really see anything that was focused on sysadmin tasking inside of containers. So we're going to try to put together some best hits, maybe some links to other references that are good. And if you search around, what you find is a lot of people talking about introducing Docker to the sysadmin. So it's like you'll see stuff that says, Docker for the sysadmin, stuff like that. Well, I'm sort of doing the opposite. I'm saying, hey, you already know basics of Docker. What if your job as a sysadmin had to always be in a container, right? Obviously, that's not real, right? None of us have to do that. But what it does do is it forces you to learn how things work in a container. It forces you how to think about doing activities in a container while still also maybe having a bunch of bind mounts or changing the namespaces so that you have access to the host NIC instead of just the virtual NIC inside your container, stuff like that. So it's an interesting exercise, I think, because every time I go through something like that and I say, well, let me do that server thing in a container, it always causes me to learn something. And I learn a new command line way to do something. I might learn a new tool that previously I didn't know because maybe it has to be command line based, stuff like that. So none of this stuff really today is from memory. I'm going to go sort of from a list, and then a lot of this stuff I don't even have really pulled together because we kind of did it last minute. So it's going to be an exploration and it's going to be fun. But this page on my website will be where we add stuff tomorrow, possibly even this weekend. And if you follow me on Twitter or Facebook, or if you are in the Slack for the Docker Mastery courses, then you'll see updates there as we post some more stuff here to hopefully help you on your sysadmin journey inside a container. All right. So yeah, that URL is here. So the first thing, before we get into utilities, I want to just make a reminder. This is sort of like me standing on my sysadmin soapbox. So when I explain Docker to people, I always am explaining it from the perspective that you may be sysadmin or you may be a developer, and that I don't prefer one or the other when I'm trying to explain it, right? Now, if I know my audience, I'm going to try to give them terms and analogies that relate to them. But a lot of us today, I think, do always, there's no person who's just a sysadmin or just a developer anymore. I think even if you're a sysadmin, you're probably still writing or editing or even reading scripts. And that is tipping your toe into the development world where you're learning automation and how programmatically things can run, right? And same thing on the DevOps or on the dev side. If you're just a pure developer, you probably have to on occasion deal with a server. You probably have set up servers on your own, even if they're just in the cloud, to run an OS so that you need something. And that gets you have to learn a command line usually to do that. Even on the Windows now, there's more and more stuff that you have to do from PowerShell. So when you're in the dev world and you're having to learn those command line tools, that's tipping your toe into the sysadmin world. So I don't feel like any one person is exclusive one or the other. It's just a question of where we are on that scale. And when I talk about Docker, and sysadmins who say, well, we don't run Docker yet, or we don't need Docker, why would I ever care about Docker? Obviously, I think eventually everyone's going to have a job that Docker is a part of your standard tool set. But, and that's why I do what I do. But one of the things I want you to remember are that when you talk about Docker, it's no longer just it runs a container. It's a lot of things. But the two things that I always focus on day one, really the first 10 minutes when I'm spending time with someone, especially a sysadmin, is that Docker provides you two things you didn't previously have. And the first one most people don't really think about. It is the image format. And so when you think about Docker Hub and a Docker image, those are something that basically Docker, the project, created out of the box 6 years ago when they decided that we are going to create a common package format and a common package distribution method that works across every OS, every modern OS, and runs with the similar commands, if not exactly the same commands, on those architectures. That had never been done before, right? We all, like on Mac, I have brew, which is pretty cool. On Linux, you have apt or yum. You might use pip with Python or npm with Node. On Windows, you have PowerShell, but usually you have to do something like chocolatey or nougat or something like that. And the reality is that every OS had their own specific tooling for downloading and installing software. But if you start focusing on the Docker toolset, you get a single package format regardless of the OS, regardless of the binary format or the architecture, 32-bit, ARM, 64-bit, mainframe, it's all the same. So that is one of the two pieces of the puzzle that really set Docker apart as an easy tool set for getting stuff. And that's going to make an advantage for you. That's going to give you an advantage as a sysadmin, because that means now you can store your stuff in Docker Hub on a registry somewhere, and you can get at that as long as you have an HTTP outbound port, right? You can get that, pull it down, and run it on a system, and then with one line, delete that from the system and know that you didn't leave bits around. You didn't affect the system somehow. And that's really powerful for a sysadmin, is to know that I left no trace, right? I didn't install utility, then run it, then remove it, and then realize that maybe it cached some files and left over some logs and things on the system, right? The second part of that is that you can run things in isolation. And for a sysadmin, that can be a problem. If you're spending your day living in root because you're running on servers and you're running as the domain administrator in Windows and you're just normally basically got access everywhere, containers can seem like a barrier. They can seem like a thing that you wouldn't want, because now whatever you're doing in that container is usually very isolated. So when I talk about containers to people and I explain that it's really this package format for packaging up apps with all their dependencies and distributing them wherever you need them, and the other part of it is running that tool or that application, that server, whatever you need, in isolation, and only giving it, it's basically denied access to everything by default on the host. And then you can give it more permissions. You can give it bind mounts. You can give it the host NIC, basically by giving it a host network, and that gives it full access to the NIC if you want to. You can give it privilege mode, which essentially is kind of like giving it root access on the host and giving it complete access to do whatever you want. So those things together, if you know them well, allow a sysadmin to use the packaging format and the container sort of restricted runtime, use those to their advantage. And I'm not going to claim that I'm the world's best whiz-bang sysadmin in Docker, because I too just want to do the easy thing and run something on a server without having to spin up a container and figure it out. But that's why we're here. So let's get to some examples, and then between now and the end of the show, I'm going to be going through some of your questions, and we'll just spin up some stuff. We'll do some stuff at the shell and see what we can learn. All right, so a lot of this is me spending time at the shell, right? And because Docker is primarily a shell tool, a command line tool, although there have been plenty of attempts at running Docker things in a GUI. In fact, if you use Visual Studio Code, if you're someone who ever even just edits a script, even if you're a sysadmin, check out Visual Studio Code, because it has a Docker plugin. And let me just I didn't plan on doing this, but I just want to show you, because Visual Studio Code, let's do this. Visual Studio Code has a Docker plugin, so it does allow you to have sort of integration. What that really means is if you ever have to edit a Docker file inside of here, if I just created a file, I would have an option for Docker. So if I did things like from stuff like that, I would be able to get command syntax. Probably not doing it because I need to throw it in there. Yeah. So, if I typed in, see how it's starting to give me various images, something like that. So you get that advantage just in an editor. Now, even if you're not a developer, I would still recommend checking out Visual Studio Code, because it has started to become a really, really great tool for sysadmins, not just for Docker, but it does Terraform, it does Ansible, it has all the different formats of files that you would want, and you just add plugins for that. But the one with Docker allows us to sort of look at Docker, see what images we have on our machine in the GUI, see what containers we have running, which I don't have any running right now, I can connect to registries and do stuff right inside the GUI. So if there's ever a GUI that I'm going to use, it's probably going to be that one for Docker. There are plenty of other attempts out there at them, including some cool ones for Kubernetes that IBM recently released. We will probably have to put that in the show notes because I can't remember the name of it. But they created a nice little GUI if you're into doing stuff locally on Kubernetes. But that's about all the ones I know. If you're on a server, Portainer is probably the best one there. Let me just show you Portainer. Because being a sysadmin means that sometimes you'd rather have a GUI than a shell. And Portainer, a lot of us talk about in terms of Swarm, but it's not just for Swarm. It actually can just run against a Docker engine, so any Docker server. You can put Portainer on there, and you can run the Portainer agents on other servers and administrate it from a single console. So it's pretty easy to set up. I have examples. You'll see several examples today, which is from my dogs versus cat repo. So if you go to dogvs.cat, right, like that, dogvs.cat, I have a lot of examples there, and most of them are focused around Swarm, but one of them in there is how to launch Portainer on a Swarm, which is very similar to how you would launch it on a Docker engine, even if you didn't use Swarm, or things like running commands automatically in the background every day. And so the first thing I want to talk about, in terms of an example, are running sort of what I would call either cleanup utilities or logging utilities or backup utilities, stuff like that in Docker. If I'm going to run a server, let's say MySQL, if I'm going to run MySQL on a server in a container, then I'm going to want to do the backups of that container from a container, right? I'm not going to want to put my backup utilities on the host. And in fact, once you get to containers, one of your goals, especially as the sysadmin running these systems, is that you don't want to put any utilities on the host, right? You don't want to put any utilities on the host. You want to keep those in containers. And so you're probably going to start making your own special sysadmin images so that you can quickly download those on servers, and it has all the common utilities you might need. So one might be, I need to do backups of my MySQL server, right? Say my MySQL 5 times. So in this case, let's say I have a Docker container running of MySQL, but if I need to run a command like a MySQL dump against that, then you could do a simple Docker run. Obviously, if you're on a Swarm or Kubernetes, you would want to spin up a pod or a service to run this in the background. But you can do a run, and then maybe I bind mount a location, right? Like maybe I say I'm going to bind mount on my host the backup files. Now, ideally, you'd want to run a utility that maybe gets those files off the server. But what if you're in AWS and you have a special EBS volume attached to that server just for storing backups, right? So maybe that's on a special location and it's backup volume, something like that. And then inside the container, maybe I'm just going to put something in temp because I really only need that file temporarily while I'm backing it up. And then you would run the MySQL image. Now, ideally, you're going to run the MySQL image that is the same version as the MySQL server. And what I'm doing here is I'm going to allow this to talk across the network, the Docker network, whether I'm on Docker Engine or Docker Swarm or doing Docker Compose. So you could do network, let's say you had a MySQL network just for that MySQL server, and then you would run the MySQL image, and then because the MySQL image contains all the MySQL utilities, you would do something like a MySQL dump. And then I could do something like a root, and I think it's a password, right? So this is contrived because I don't actually have a real server. I'm not going to do a real backup for you, but then I'd run the MySQL image. That's the first MySQL. The first one is MySQL. Here, let me just make it a little easier to read. MySQL net. Let's just say I had a network called MySQL net. That way, this container is going to run and talk to the MySQL daemon over the network, right? And I do something like that. And then I would do a host. Well, let's just say all databases -- host. And then, of course, that's going to be the name of the container or the container alias that's running the MySQL daemon. So maybe that is just in this case, because I'm running it in Swarm, maybe it's on a Swarm network, and so I have easy names for all my services, and my SQL server is just called MySQL Server. And then I'm going to put that into the temp directory backup. I'm just going to call it a backup file. Now, in this command, if I properly escape it by putting it in quotes, I can probably do something like, let's see, the date. I'm copying from a command. This is actually an example straight out of the dog versus cat repo. Date. Let's see what. No, we're going to do a plus %H. So this is going to be the hour it was taken. So the date plus the hour. All right. And when I run this command, it will automatically make the file, dump the whole MySQL server into that file. And that file, because the temp is bind mounted to the host, that file will live on my host. Now, that's not the complete equation, because you're going to want to run this on a regular basis. Maybe you run this every hour. In the real world on AWS, I'm probably using their hosted MySQL, so I don't have to do these backups. But hey, if you're just running a small little system, you're just running on DigitalOcean or something, and you just want to back up your MySQL, this is how you would do it, or an example of. Some people might go and jump into an exec command inside the MySQL server itself. The advantages there is that you don't have to go over the network. The disadvantage there is that if you're in a cluster, if you're in a Swarm or a Kubernetes system, you may not know where that container lives. So that might be part of the problem, is you may not know the container name, you may not know which server it's on. So when you run it over the network like this, you just have to make sure, at least in the Docker and Swarm world, you just have to make sure you're on the same network, on the same virtual network in Docker. And then the rest of it, like if you did something in Kubernetes, you could probably find more advanced tools that would do automated backups for you. So this would be an example of how, and I get this question all the time, how do I back up stuff? How do I import? You would do the same thing here. You would bind mount the data you need to import. You could run the command, because most of these commands for Postgres and MySQL and all of them, they run over the network as well as locally against the database server. So something like that. All right. So that's kind of the first one. Now, if you ran that same command in a Swarm service, or maybe you ran in Kubernetes or something, you could do. Let me show you what I'm seeing here on this. All right, so in Firefox, which one did I put it in? Ghost. So I'm going to actually copy this command out. And so Wellington's saying $2 signs. Actually, I believe it needs to be $2 signs in this case, where I'm putting it inside quotes. So this one right here, this is a good example. And this is some people might look at this and think, oh, that's interesting, but does that really work? And what I'm doing here is I'm running a Swarm service that runs, basically it uses the standard MySQL image. Let me just zoom in there. And it's doing a while true. So we're doing a bash loop every hour to run a MySQL command. So while true meaning it's always going to be true, so it's always going to run. And it's going to run the MySQL command, the MySQL dump command we just saw there. And we're going to take the password, and you can see later in this file, I actually pull the password from a Swarm secret, and I pull it out of an environment variable that's stored on the file system in an encrypted format. So it allows me to run this automatically without having to put a password into my service create command, because service create commands typically are stored unencrypted in the service definition, and you wouldn't want to store a password in there. So that's how I would do that. And then the rest of that command, and then dumping it into a .SQL file, which is just a plain text file. And then I sleep for an hour. That's basically what the end of that is. So you can do a lot of utilities and sort of stuff in the background just by doing simple bash loops without having to either write a shell script file or some sort of domain-specific language, right? You could just do a single command. So, yeah, why are there two $signs? Because in the command line, the way I understand it is when you're doing something inside a Docker and you're seeing this command, you're basically having to escape the $sign. So the second $sign is the actual environment variable. The first $sign, I believe, is how you escape to let it know that you're about to give it an environment variable. So I could be wrong on that, but I believe that's why there's two there. Notice that I'm having to actually run sh at the beginning so that I'm ensuring that I'm running this inside a shell and that I get the shell environment and that I'm quoting the whole thing there with double quotes. The double quotes will allow me to expand the environment variables inside. If I didn't use double quotes, it wouldn't do that. So, yeah. All right. Great questions. All right, so before we go to the next one, let me scan through, see if I can find the first question here. Biker's got a question here, not specifically around sysadmin, but certainly if you are a sysadmin, you're probably one of the ones that has to decide where you're going to store your registries. So yeah, sure, this could be a sysadmin thing. Various topics, repositories. So there's lots of repositories out there. You are looking at Azure ACR and licensing Twistlock to do the CVE scanning. So the thing about registries is, so when he says various repository options, what we're really talking here about is what registry options are there. And there might even be a list. Let's go to Awesome Docker. So Veggiemonk has a really great, actually, I think he has a website now, yeah. So this is Awesome Docker, which is basically a list that's kept mostly up to date on all things Docker. And underneath here, we could probably find registries. And you can get this insane list of, which is probably not complete, but basically everyone's doing their own registry now. So when you start comparing and talking about registries, there's the cloud-hosted ones, which are largely the same. And the nice thing is with those is they're typically integrated with that cloud's tooling, so it's a little easier for you to use all the other features of that cloud with that registry, especially for something like if you're in AWS and you're going to deploy on ECS or something like that, using their registry might save you some steps and effort, as well as the fact is you don't have to monitor and maintain that registry. Maintaining your own custom-built registry is a little bit of a pain because it's mostly just an HTTP storage system. That's really all it's doing. It's got a differencing engine in the background that makes sure that you don't store the same images twice or the same layers of images twice, so it's efficient in that way. But it's really just a storage system with a web API in front of it. So at the end of the day, it's kind of one of those boring things that I really don't want to have to run myself. But I would lump these into three areas. One is the cloud-hosted ones. One area is what I would call artifact storage that happens to also do container registry. So JFrog might be a good example of that with their Artifactory. There's other ones on here, I'm sure. Nexus is another one. And these types are basically, they're familiar to developers, not so much maybe to sysadmins, but they store all types of artifacts, things that are coming out of your system, whether it's NPM stuff or apt-get, binaries, basically package formats from your code. So it's not necessarily always storing your code, but all these systems now also store containers. So they themselves can be container images. You might even put GitLab into that, because GitLab is sort of a universal developer and DevOps toolkit, and they also have their own container registry that's comes out of the box. So it's sort of these types of tools do lots of things, and storing images is just one of them. And then maybe the third type of container registries is the ones that really just do that, right? DTR, you mentioned, Docker Trusted Registry, is the official one from Docker that you pay for. They have the open source registry, which is called Distribution. That's a free one. But the free ones are always going to be, the open source ones are always going to be more work for you to maintain and support. So for my clients, I generally do not recommend those out of the gate unless they have specific requirements that require that one. I usually want them to buy it, either buy an online service that just does it for them, or buy one that at least automates like the cleanup of images, because when you delete images, there's this whole background process where it has to go through and find all the layers that are no longer needed in storage and clean those up and save you space. So that garbage collection is a big deal in image registries, and it's not something that you get out of the box with some of the free ones. So when it comes to the individual features, I'm not well versed enough in all of them to actually give you a full comparison. So that's probably what you were asking for, Biker, was give me the differences between DTR and ACR, and I'm not really going to have those. It's going to be something where you're going to have to probably just use them. And I'm sure that if you go back to Docker and say, we're considering ACR, why should we buy DTR? And so, ask Docker to give you the competitive comparison of their product over the one in your cloud, right? Because one of the things that Docker talks about is that they're cross-cloud, right? So you can run DTR everywhere, not just in Azure. So that's probably one advantage. But I bet you that they have some sort of competitive information on what would be better for you to use DTR for than ACR out of the box. So good question. Let's see. So I got a question here on container is up state, but the internal function is not working properly. How to check the status? All right, so this actually leads me into a little bit of monitoring and logging, which is definitely more in the sysadmin role than the developer role. So let's go back to the command line real quick. And when we talk about logging, so let's just talk about logging for a minute. And a lot of people, let's say I do, since we're talking about MySQL, let me do a MySQL. All right, so I had to get the environment variable that I need. MySQL, because you have to start MySQL with at least something about a password, right? Root. Let's do actually random. Let's do the random one, because this will actually get me 2 birds with 1 stone. So let's do MySQL random root password. So I don't have to specify one. I'm going to run it in the background. I need a name. Let's call it BrettSQL. And then we're just going to run the MySQL image. And by the way, generally, like if you're on Mac or Windows, you don't want to bind mount the databases, because that would be going across OS, and that would give you poor performance, and sometimes it won't even run. So generally, if you're on Mac and Windows and you want to run a MySQL server, you would specify a volume to keep the data, but you wouldn't bind mount that volume. So pro tip on that one. All right. All right. So that's going to run in the background, and we'll get some logs out of that. And So when we talk about logging, so going back to this question on, I've got a container that's up, but it's not working. What do I do? So the first thing I'm going to want to do is, if it's a web server, obviously, does it respond HTTP? Is the port open? So I might test ports first, right? You can use various tools for that, but that doesn't really change because you're usually trying to access that from outside the network or from another container. So you could, well, let's leave the networking stuff for a minute because we can go through networking stuff separately. But right now, I have 3 types of logs, right? So if I do a Docker PS, oh, did I not do it right? I have to do this true. Haha. All right, let's try that. Now, if I do a PS, I should have that running. So Docker logs is an obvious one, but those are app logs, right? So one of the things that I want to understand about a misbehaving app is this a problem with my host or Docker itself, or is this a problem in my app? And the first thing that my students do is they usually go for the app logs, which is the Docker logs command, right? So I would dump all this out, and one of the things about database startup is that there's usually a lot of stuff that has to happen. In fact, in a SQL server like MySQL or Postgres, they have a script that they run through that does things like creating the root user and setting a root password, right? And sometimes that, depending on your system, that'll take a minute or two. So sometimes people aren't like students aren't patient enough to see the password. So that's my crazy long password. If I wanted to test client connectivity, that previous example, when I did the Docker run of the MySQL image and then just ran the command, I could do that with the MySQL client. In fact, if you go over to Docker Hub to the MySQL page, you will see how to use the MySQL client just to connect to the server. So that would be something I would do, is I would want to test connectivity with the client. If it's a Redis, I would want to do a Redis client connection, which you can just Google test Redis from a Redis client. So you would start another container and try to connect over the network to that container. In this case, I'm just looking at logs. But the problem is, a lot of times, is that applications are misbehaving, or there's something else wrong, like the file system of the host is full, or the host is having just general problems, or Docker itself is having problems. Docker itself, to me, tends to not be the issue. It's either the application misbehaving, or the networking of the provider of networking is misbehaving, or the host itself is messed up. It's not usually Docker. Millions of people are running Docker, so it's usually pretty stable. So the next thing after these logs is, if you are on a host and this is a common thing in Swarm, is there's lots of other types of logs. In fact, there's 3 main areas of logs. There's the application logs. There are Docker's internal events, which are technically a type of log where it spits out the events of things that are happening in the background. And then there is the logs of systemd, or whatever is running your Docker engine. If you're on Windows, on a Windows server, that's just going to be Event Viewer. If you're on a Linux machine, you're going to look at journal D with journal control command. So what I might do here is, we've done the log command. Let's say we did the Docker logs, and there was nothing there. So the next thing I might do is, what's going on my Docker with this system? So one thing I can do is just do Docker events. And Docker events is basically an output, a real-time output. You'll notice that it's not finishing the command. It just sits there. And it's everything that the Docker engine, including Swarm, is doing on that node. Now, if this was a Swarm manager and I was doing Swarm things, this would show me Swarm events in the managers as well as the local node. If this was a Kubernetes system, it would show me the events coming out of that Docker engine that Kubernetes was telling it to do. All right, so there's no... If you go look up the Docker events command in the Docker documentation, you can get a little bit of a history. But the last I checked on the events command is it only stores like the last 1,000 lines of events. So even if I did an until or since, rather, if I did the since here and gave it some random date from days ago, I would really only get the last 1,000 commands. So if you've got a significantly big system, that 1,000 events probably happened in 10 minutes. So so the thing is, what I would do here is I would have, let's just say I had Docker events running, And then over here, I did a Docker run, something like that. And you'll start to see over here on the left that I've got events happening. And events would be things like it pulled an image, it started a container, it stopped a container, it ran an exec inside a container, it created a network. So this isn't going to trace packets or do any sort of inspection into your app. This is about Docker doing a thing, right? And in the background, if you're on Swarm, for example, in a health check, every time you do a health check in Swarm, my camera keeps losing focus on me. In Swarm, the health check is running, let's say by default, it runs every 30 seconds. Let's say you do it every 5 seconds. You change your health check. What that's doing in the background is a Docker exec command every 5 seconds. So on that host, you would see one of these events every 5 seconds. It says, creating Docker exec command inside this container ID. So this is something that I look at to see if there's bad behavior or something that's not happening like it should, or something that's failing, like pulling an image. At times when you have either your password isn't correct for the image registry or you lose internet to the registry. In Swarm and in Kubernetes, it sometimes can be hard to figure out what's going on. But in the background, Swarm and Kubernetes are really just telling Docker to pull an image. So running this events command, if the image was failing to pull, I would see that here. I would see it say image pull, and then it would give me some sort of error coming out of it, depending on it would give me an error message, stuff like that. And you can change the format of that, how it looks. By default, it just shows you sort of this logging format, but you can turn it, I believe you can turn it into sort of like you can turn it to JSON, stuff like that, to get a more, a good format out of it. And then you're going to want to take ideally in a production system, you're going to want to use something to get these events out. So you technically have ways to do that. Just Google it. There's various ways to do that. The next thing there, if you're talking about monitoring, is there is a Docker monitoring endpoint that will get you all sorts of stats out of Docker. We're not going to have time to go into that today, but if you just look up Docker monitoring endpoint, or I think it's Docker, it's a different port that gives you the statistics out of Docker, and tools like Portainer and other monitoring tools, Datadog, Sysdig, all those tools will pull out those monitoring statistics, like how many containers are running, and the names of those containers, stuff like that. It'll give you sort of monitoring type stuff. But from the command line, this events. Now the next thing you want, so now we have the event, the application logs, the things that Docker is doing, and then the system logs. So if I'm on a Docker, then this is a different Docker system. So I'm now on Docker. I'm on a Docker Ubuntu server, and I've got one little thing running. So I've got Elastic, I think, running on this. So in here, I could do a journal command. Now, this is just me running on the host, and I would do against the Docker engine. So this is giving me the daemon logs. So if you've ever looked for the debug option, you can start Docker with a debug option, which will put a lot more in these logs, right? And this doesn't tell me anything about my app. This basically gives me the low-level stuff happening in the Docker engine if I think possibly my Docker engine is full, or my Docker engine is bad. So a good example that I see a lot is the file system gets full. And of course, it's not like when you log into a system, it'll say file system full all the time, or almost full. So, or a particular amount that you have to a particular volume is full or something. And you would see that in here. So you would probably scan this for the type of event. So you see over here, it's a little hard to see, but you see this level. So you would look for level error. And that, if you just filtered for that, maybe even using grep, you would be able to get any errors that were coming out of your Docker engine that possibly might be affecting your app. So there's a lot more to this. I actually talk about this in my Swarm Mastery course as something that you need to learn. There's these 3 different levels. And if you're just looking into your application, you can always just exec into your app and then look around inside that container, look for files that might have hidden logs in them or something like that. So I might do a find command inside my container to find any files with a .log in them, because maybe my app is not properly logging to Docker like it should, and it's just logging to the file system, and that's why maybe I don't see the errors or the problems coming out of my app. But those are some tips. That's a great question. All right. Looks like we got a lot of questions. This is a great topic, so we're probably going to have to do another one of these because we're already at 2 o'clock. But let's see if I can't do some rapid fire stuff here. Let's see, we have a question here. I have a non-HTTP service based on a distrolist/scratch image. How would you do a health check on this kind of service? Any thoughts or best practices? Honestly, this is going to sound lame, but until somebody tells me a better way to do this, this is my answer. You write something to the file system, and then you check that file. It sounds kind of silly, but really a monitoring endpoint requires that you start some sort of server, probably a web server or something, inside your app. And if your app isn't doing that, like you said, if it's a non-HTTP based system, then you need some way for a generic type of checker to check your app, right? And so if it doesn't have, like if it's not something like Redis where you have a client that can speak Redis and stuff like that, then the thing that I've come up with is you write some health check functionality into your app, assuming that you have control over this app and you can add functionality to it or request functionality. So have this app write a health check file, and maybe it writes that file out every 5 minutes or every minute or whenever you want it. And maybe that file just exists. There's nothing in it. And in theory, in your app, if your app was spitting out that file, then your app is working. Now, as you get more advanced, you might actually put some data or information in that file. And because that file's there and it's just plain text in your container, then you can have the Docker health check commands looking at that file and inspecting it however you'd like, right? Like you could go in there and curl it out. You could look for a certain value in the file. Maybe even though it's not an HTTP, you just consider if it comes back with a 200, then that 200 means that the app is good, right? So that would be similar to an HTTP endpoint. And then you could just have your health check command be basically a bash command to curl out that file. Now that means you also would need curl inside your image. So make sure you have that. And you would do a curl out of that. And I say curl, but it could be any other text reading utility. And read that file out. And if it finds the value 200 is somewhere in that file, and the file date is within the time range, right, the last 5 minutes, then the app is good. But if the app sort of gets in a hung state and it's not able to write out that file, or there's something wrong and it's not writing out the file, then your simple little one-line bash health check would fail because the date was old. It was an old date. So that's kind of a simplistic example, but if you don't have an endpoint, then to me, the writing out information into a file system on a regular basis and checking that file, both for timeliness and for information in it, is the next best thing, I think. All right, and that works with all health checks, whether or not it's Docker, Swarm, Kubernetes, or whatever. So great question. Exactly, we can get the reason for the exited state. Yeah. So what you're talking about is when you do a Docker PS command, right? And oops, this is what we want. If I see my old containers, actually there's no old ones because I just did a brand new install of 1903. By the way, next week we'll talk about it at the end. Next week we're going to have 3 shows. I'm going to host 3 shows throughout next week, and you'll see email announcements. So if you're on my Twitter or my newsletter or anywhere else that I put stuff on the internet, you'll see some announcements here in the next couple of days about next week. We're going to have a big release party for Docker 1903. So I'm running Docker 1903, which means I completely wiped it and I have none of my history. But if I just did a Docker PS and Docker PS-A. So, all right, so I force killed a container, right? And you see the exit status here. So because the thing killed itself, it's not probably going to have any logs. So if I did Docker logs, on B4. Let me take away your little question here so we can. It's actually a great question. If you take away the Docker logs, there aren't any logs there for that because it was just Nginx. There was nothing that happened, but it did have a bad exit status. Exit 137 is a error type of exit status. So I could just Google what is error, exit status 137, which does have a standard meaning, I believe. But I could also do a Docker inspect B4, and then I could grep for 137, see if I can get the short thing, exit code 137. So if I do the inspect, yeah, so see how there's no error there from the app, so it's not going to give me that information. So the best you can do in this case is you just got to go look it up. The application didn't provide me an error message with the error code, but if it does, if your app does have that kind of problem, or if Docker had a problem pulling an image or starting a container or doing any sort of those things, that will be here in this inspect. So always inspect the container after it's stopped, or even if it's still running, or if it's restarting, like in Swarm or Kubernetes, if it recreates it over and over again because something's not right and it's not starting right, you got to go inspect that container while it's stopped to see what that exit status is, and it'll have an error information on the error code there. If you're in Swarm, another one of those tips is you can do a Docker inspect of the service. And then if you don't see anything in there, you can do a Docker inspect command on the task ID. So you got to do a Docker service PS to list all the tasks, and then pick one of the failed tasks and go do an inspect on that. And that will also have JSON information, including reasons why it failed. For me, it's most often that I forgot to include the authentication for logging into the repository to pull the image. So it's a private image and I didn't give it permissions. So that would hopefully help you. Yeah, so great discussion, Biker, Charlie, everyone else in there. Container of Linux will run on Windows and vice versa. So technically, no. You cannot have one. I think what the question here is, will an image run cross-platform? Yes and no. So you can't put a Linux binary on a Windows machine and run it out of the box natively. But if you're running Docker Desktop, then obviously you can run on a Windows machine. You can run Linux containers because that's what Docker Desktop does for you. But in the background, it's really just running a Linux machine. There are modern images now that run. Basically, there's multiple images with different tags inside the same repository. And so, for instance, if you run the Python container or the Python image, if you run that on Windows and you run it on Linux, the Windows one will get a Windows binary version of Python, and the Linux one will get a Linux variant, a Linux binary. So it's technically two different images with two different sets of files and directories. But you would type the same command, and it would run differently on two different systems. That is because of something called Docker manifests. So if you're interested more in multi-architecture setups, go look up Docker manifest files, which is a way that images describe different tagged images for different architectures and operating systems. It's a pretty cool thing. Also, go look up like the Java image, the Python image. Those images, those official images have multi-architecture support, and they will show you different setups for different OSs, right? Like if we went and looked at the Python one over here. Let's see. Went to Hub, look up Python. Go to Python. And if you scroll down, you'll notice that Windows Server Core is listed in here. And then you have ones like, different Linux variants, different Linux distros. But the Windows ones are in here. And so if you typed on a Windows server and you were running Windows containers and you typed Docker run Python, you would actually get a completely different image than a Linux one. You get a Windows variant that is compatible with the Linux or the Windows operating system. So great question. Let's see. Let's see, any ideas for how to prevent a container from restarting if the service inside fails? I've had quite a few times when I need to go inside the container to work my sysadmin magic to debug. All right, so this leads me to the next thing here is that really in a production system, no, you don't want that. You don't want to put something in the way that is inside the container that will then restart the app inside the container. As a sysadmin, the way you're going to debug is there's multiple options, but the one you're going to want there, let's say that container was failed, but if you just restarted the app, maybe you would be able to recreate the situation. So inside here, if I did a docker ps-a, right, I have that failed container, the one that I hard failed. So I could just restart that container, right? But if you're on a production system, that's probably not going to be a good idea, right? If it's a service, then that service has already spun up a new one, and you're going to want to start that as something else or start it somewhere else. So you can take that container and all the funkiness that was in it, and you can commit that. So you can do a docker commit command. And if you look at the help on that, basically you're specifying the container that you want to turn into an image and then the image you want to call it. And that will take everything in that container, including the changed files that were unique to that container itself, and make an image out of it. Then you could spin up a new container from that image with all of those files and things in it. The reality is in your case, you're saying how to prevent a container from restarting. The reality is if your app inside is failing, you can't really prevent the app from failing, right? I mean, if it's got a problem with it, it's just going to keep restarting on the inside. So it's not necessarily going to help you to jump in that container while the application's restarting all the time. So this is the next best thing. You're going to be able to basically take exactly what was going on there. The other thing you might want to look at, and I'm just realizing, still in the browser. Thanks, Ray. Sorry. So docker commit. You can see that there. That takes a container, saves it to an image. So that's how you can save any sort of funkiness. Maybe there's funky files in there. The next thing you might want to look at, and it doesn't always work in all scenarios, but let's see. Let's just do a docker command and I'll show you. What am I looking for? Did they take it out of the latest release? Oh. Yeah, they might have taken it out. It was a feature that was in there for a while. 1 second. So it was Docker. I think it was called Docker Snapshot. Yeah, it looks like they might have taken it out. Maybe it's a depreciated feature. Or maybe I'm just forgetting the actual term. So a commit command gives you the saved image and doesn't give you the actual memory or anything like that. But Docker used to have, which I never actually ran in production, but I always knew it was there. Docker used to have a snapshot feature that actually saved the memory. Oh, it's checkpoint. Is checkpoint in there? Hey, look at that. I was thinking it was snapshot. It's actually checkpoint. So it doesn't always, as far as I know, it doesn't run in Swarm, right, or something. But check out Docker checkpoint. So what this is going to allow you to do is make a checkpoint, kind of like if you've ever done like a freeze of a virtual machine and it saves the memory and the state and the CPU cycles and all that. So this is going to allow you to do that same thing. Then you can do a Docker export. Well, actually, no, you wouldn't want to do a Docker export. You do a Docker, you would do a Docker save. So when you look up Docker save and Docker load, Docker save and load allow you to get an image out of Docker. So it's in a tarball file. And then you can load it onto another Docker system later. Now you could always push and pull images up to the registry, but if you're someone if you don't have that ability, or if you don't have private repository available and you don't want to just do that, you can always save to external disk using save and load. The difference between save and load and Docker export import is, think about it. This is how I remember. Docker export and import are commands that allow you to take the file system of an image and get them out of the Docker format. So in other words, getting them out of Docker, because you're exporting it from Docker. So you're removing it from Docker into just plain old files and folders. If you're doing a save and load, that is Docker's way to save images in an image format in a tarball. So you can save and load image formats in the Docker format, right? That's how I remember it, because they were always confusing, like which one is image format, which one is file format. So that's how I would do it. I would do maybe a checkpoint if I could. Alternatively, I would do a commit. And the commit's not going to save the memory or the exact state of when that thing was running. But you can only do really a checkpoint if the thing is running, right? That's the idea with a checkpoint, is it's a running container. So I've been told by Docker engineers that that's a great way to debug things, but I've never had to do it because I've always figured it out some other way. I've always looked at logs and other kinds of stuff. So great question. And I'm glad we got to talk about that. All right, just a few more questions, and then we're going to have to run, and we'll have to do this again so I can get some of your questions answered. Yeah, how to build and cross-compile a container for other architectures and run it. Look at manifest files, and then look at the new Docker Build X in 1903. Docker Build X allows you to build across multiple architectures at the same time. So, but if you're looking to overall architecture stuff, look at the manifest file, which allows you to have the same image repository, but different images for different architectures. Also, if you're into Node.js, I talk about this in my Node.js course. So go look that up. My Node.js course covers doing Node in ARM and Windows and Mac. Excuse me. All right, who's going to be the lucky last question here? Let's see. All right, we're gonna have two more questions here. We have a question around each replica in a container. You have 5. It says I have a Node.js server getting load balanced on a Docker swarm of 5 replicas. Now each replica in a container holds very less compute power than the host machine. So how do things get so successfully handled in load balance in a Docker swarm? I mean, after those 5 replicas won't even sum up to create great compute power after all. So I think what you're asking about is controlling where things go in a swarm, and what you want to look up is resource constraints. So it's swarm resource constraints. Or reservations and constraints. So you can constrain resources in a container, because out of the box, any container running can have complete access by default to all the resources of a host. So it'll go just as fast as the host. If you constrain it, then you are giving it limitations, like a certain number of CPUs or a certain amount of memory. If you give reservations, then what you're saying is, hey, Swarm, only run this on a machine where there are 3 CPUs available, or there's 8 gigs of memory available. So that is a resource reservation. And you can use all those together to basically control your swarm. You can also run constraints on labels. So for instance, if you have nodes that have SSDs and other ones that don't, then you would label the SSD nodes, and when you create your fast memory database that needs to have an SSD for storage, then you would make a constraint on that service to only run on nodes with the label SSD, and that's called label constraints. I cover almost all that stuff in my Swarm Mastery course. If you just go to swarmmastery.com, you can get the coupon and get that course for covering all the different details of how to control resource stuff in Swarm. Great question. Let's see. Next one. I have an Elastic Cloud. What is the best way to get Docker logs to them to be parsed? Logging drivers, or have FileBeat pick up the log directory? I haven't been able to find a good solution no log stash in cloud, so I don't think Gelf would work right. Having FileBeat collect all of the containers, but I can't parse or aggregate them well as they all are just showing up by ID. Let's see. Elastic. I have Elastic Cloud. What is the best way to get Docker logs to them to be parsed? So, I don't have a specific answer for that one. I don't think Gelf would work right. Well, Gelf is a log format, not necessarily. So I look at Logstash as a way to transfer logs to a remote system. Gelf is a log outputting format. So really, I mean, if you could have FileBeat pull out Docker logs that are Gelf in the container, and then FileBeat could pass it to something that's in the Gelf logging format. So that I look at those as working together. They're not one or the other. I'm not sure if that helps, but yeah, I don't have any better answer than that. So sorry if I don't. Sorry if you waited all this time and I didn't give you that great answer you're looking for. Let's see. Hey Brett, I want to create a swarm over multiple data centers. Is it a good practice to use the public IP address and advertise address? Okay, Rick, do not do that. Don't make a swarm over multiple data centers unless you are certain you can get sub 10 millisecond ping times between those data centers. So technically, if you're in AWS and you're using, this by the way is true of all orchestrators. They are not designed to have a single cluster across data centers. So when you think of Kubernetes and Swarm and other clustering technologies, think of one region. Now, technically, you can do multiple data centers if they're in the same region. So, for example, on Amazon, when you've got, let's say, 3 data centers in the region, right? So you have zones, availability zones, and those are technically separate data centers. So those are guaranteed to have very low ping, very high bandwidth, very low latency. Then you can operate your swarm across those. But you generally don't want your swarm to have to go across firewalls because that's going to be pretty challenging. So you usually want that swarm to be well connected, and especially like if you're on Kubernetes, you have to be well connected. You don't want to have NAT between them or firewalls that do translation. With Swarm, you can get away with it a little bit, and it technically will work. It's going to take effort. So you're going to have to use the advertise address, and then you're also going to have to use the other options. So when you create your swarm and when you join the swarm, look at that Docker Swarm join, Docker Swarm init. Look at the options there because there's a lot of options for specifying different parts like the data path and the control plane path. All those things, you're going to have to be very diligent about being correct on those. And the advertise address in that case would be the public address. So that way the other things can find it through the public address. But that gets really complicated, so you're going to have to do a lot of practicing and always make sure those data centers are very close together and very low latency, because otherwise everything in your network, all your networking and your Swarm decisions and your Kubernetes decisions will all get pretty slow because they constantly chat all the time. And if you have high latency, like 100 milliseconds, 50 milliseconds, things are just going to start to get slow. It's not that it won't work. It's just going to be unbearably slow for you. And it's also not a great design. So the design of these things is to not necessarily run across far distances in a single swarm, even though you technically could. So yeah, hope that helps. That's also in my Swarm Mastery course, as well as in my DockerCon talk from 2018 and 2017 specifically. So if you go to YouTube and you just look up, Brett Fisher, DockerCon 2017, you would probably find that talk where I go through different Swarm designs and different things to look out for in designing your architecture for Swarm. All right, I think that's about it for questions. How to check what Docker volumes are attached inside a running container. You're going to have to basically run a bunch of commands. You're going to have to run if you do a Docker inspect on the container, you will see all the volumes that are attached to that container. All right. So when you do an inspect on a container, it lists all the volumes, the bind mounts, everything that is basically the entire configuration of that container. So check out Docker inspect. And let's see. One last one. Good tips regarding my service restart, but what if I'm after it to be able to debug an initial setup or a whole range of services? when one service fails because of some dependency, I want to go in and test connection to those dependencies with ping curl telnet. It's a fairly complex environment with multiple overlays and proxies. So you would start, so if you're talking about Swarm, you would start a container inside those networks or a service and then attach that container with exec. And a great utility with lots of networking options is NetShoot, which we talk about quite frequently on this show. So the last tip here is NetShoot. NetShoot is essentially just a container image that has a whole lot of Linux utilities built in. So it's nothing really special about it. It's just convenience. It's convenience of adding all of the networking utilities and system utilities that you might need. And there's lots of examples here. And it's quite popular. It's used on Swarm, Kubernetes, Docker engines. And so it'll probably have the utilities you need out of the box so you don't have to manually install those. So you would run this inside your Swarm and you would attach it to either a service, or you would, if you wanted to run it directly with a Docker run-it, then you would have to make sure that those networks you created in Docker are attachable, specifically in Swarm. They'd have to be attachable networks, which unfortunately you have to do when you create those networks. But if you haven't done that, then create it as a Swarm service, run NetShoot, and just run a bash loop or something that would keep it open while it's running, because it's not really doing anything by default, and then find out what host that's on. You can actually run the service with a constraint that forces it to be on your host, then then jump in with an exec command into that, and basically you'll be inside the network with all the utilities that you can run remotely against your other services that are running inside those networks. So hopefully that gets you farther along the path and solves that problem. So, well, thank you so much for coming. This week, again, this was all about sysadmin stuff, which we could talk about forever. And let me know with a thumbs up or comments on what other topics you want me to talk about in the next Sysadmin edition for Happy Sysadmin Day. Next week, again, we're going to be back here 3 days next week with Docker captains, Docker engineers, all talking about the Docker 1903 release. You'll be seeing that soon in my announcements through my Twitter account or my Facebook or my newsletter or wherever you find my stuff. I'll be talking about that as we announce those dates. You'll be able to watch that on my channel on YouTube or on Docker's channel on YouTube. Docker's official channel will be dual streaming. And for those of you that are sysadmins or have anything to do with sysadmin jobs, thank you for all that you do. I'm glad we have a day of the year to celebrate. And I'm going to give you a virtual cupcake, and enjoy, or cheers to a beer. And why don't you take a break for a few minutes, go get a cup of coffee, and don't do anything for anyone. Don't answer any support tickets. Just relax. You earned it. Happy Sysadmin Day. And I'll see you next week here on YouTube Live. Ciao.